It is now recording. Here we go. Exercise 2A. We're now moving into chapter 2. Thanks, team. So we're now moving into chapter 2. So with your notes in front of you, we're just reviewing. So this week, I'm only really looking for exercise 2A. Let's review your angles and your properties. That's what we're going to be focusing in chapter 2. So let's start off. Angles that are between 0 degrees and 90 degrees is called what? Hands up if you know. Eknor. It is called an acute. If you didn't know, write it down. It's acute. Sorry, let me just fix my handwriting. Acute. It's an acute angle, which usually looks something like this. So the angle that you make, that's going to be starting 0 is horizontal. So 0 degrees is horizontal. And then when you go up but not less than 90 degrees, that's called acute. Next one. Angles that are exactly 90 degrees is called what? Hands up.
Right.
Belinda? Right angled. Very good. So that's when you do make exactly, again, this is 0 degrees. You make a nice 90 degrees, and we show that with a corner box. Okay, so a little corner box indicates that it is 90 degrees or perpendicular. Attila. Thank you. Next one is angles that are between 90 degrees. So now that you started here, you've gone acute, then you went to 90 degrees. So that angle that it's making there, that's 90. But then after you pass 90, but less than 180, what is that called? Hands up. Someone different. Is that Hamza with your hand up? Did you have your hand up? No? Okay. Do you know though? Obtuse. Yes, that is correct. Obtuse angle is when we say it's greater than 90 but less than 180. And so here we go. Let's draw what that looks like. This is the angle where this is 0. So you start off with 0 and you have to rotate this far away. So that open angle there, that's called an obtuse angle. It's more than 90 but less than 180 degrees. Then when you finally actually hit 180 degrees, what is that called? Let's go with someone else. No one else? Okay, let's go Garissa. Straight angle. So this is called a straight angle. It's easy to remember because it literally is just a straight line, which we know makes exactly 180 degrees. Okay, so 0 degrees starts here. And if you did a 180 turn, you're literally in the other direction. Okay? Next one, angles that are between 180 degrees and 360 degrees. I already chose you three already. Let's go with someone else. Anyone? Let's go Willem. Do you know the angle that's called 180 to 360? What is that called? Reflex angle is correct. Reflex angle, let's draw it again. So this is now starting at 0 degrees. And you go anywhere that's past 180. Okay, so you can see the angle that I'm drawing, it gets bigger and bigger. That little curve is getting bigger each time. So bigger than 180 degrees, that's called a reflex. And then finally, your last property, if it's exactly 360 degrees, it is called what, Charlie? Full angle or, starting with R, rotation or revolution. Okay, so I'm going to write it all down. Full angle revolution, or what did you say again? Rotation. Okay, so it's literally when you do a full 360 turn, so it actually looks like a circle. So starting off at 0 degrees, you literally went all the way around and back to the same spot. So if you say that I did a 360 turn, you essentially ended up back at the same spot. Okay, whatever direction you're watching. So the next two are key terms that I find students tend to forget, or at least they mix the two. If a pair of angles is added up to 90, it doesn't have to be a pair, it could be just a set of angles. If it adds up to exactly 90, it is called what? Let's go Belinda. Complementary. This is not the L-I. I is complement, meaning like I'm flattering you. It's complement. Complementary. So those angles are complementary if they add up to 90. Tell us, settle down. If not, you can sit over here, okay? Next one. If pair of angles add up to 180, then it is called, starting with S. Let's go with Yichen. Do you know? No? Let's go Jacob. No? Let's go with Josh. No? Ryan? Oh, good. We've got a whole row there. Anyone know? Eknor? Supplementary. Write this down. Supplementary. You're going to need to know these terms because we'll use it in our proofs when you start to explain how you know a certain angle is what, you need to say one of these terms here. Next one. Also, when two lines intersect. When they intersect, so the diagram I've drawn there for you, when two straight lines intersect, okay, opposite angles, okay, so these are called opposite angles. This angle is opposite to this angle, are equal. So whatever this angle is, it'll equal to exactly whatever that angle is there. So e.g., for example, if this was let's go with 65 degrees, this one would also be 165 degrees. So opposite angles are equal. This is called what? There's a name for this. Only happens at the intersection of two lines, no matter which line. What is it called? It starts with V. Oh, it does go vert, but not vertices. Vertical, but missing a few bits. Oh, good. I'll write it down. Vertically, opposite. This is going to be key because that's part of your parallel lines property as well. So vertically opposite is a key one. These are the key things that you need to know. So these are all the names. Your task for today is 1, review them. 2 is to apply them. So you need to be able to identify and then solve. So identify is the first skill. So in your fluency section, that is to identify them. Then once you can identify them, can you solve a problem using those properties? So here's an example. Let's have a look at this one. They say determine the value of the pronumerals. These are your pronumerals. These are angles that I don't know. Shh. Listening. We know that the angle from here to here, so from this line, if I created that much of an angle, that's 40 degrees. But from here to make this line, that's A degrees. I don't know what that is. But I can use a property from what I've seen to solve for A. Anyone see a property that is very clear for us to figure out what A must be? Let's go with Adele. Beautiful. So Adele said that this is 90 degrees. But how do we know that this is a right angle? You can't just look at a diagram. What's a key hint? Very good. So over here, there's a box. If this is right angled, then this also has to be right angled because remember, that's a straight line. So it has to add up to 180. If that's 90, this must be 92. Now, if this is 90, so 40 plus what makes up 90? 50. So A must be 50 degrees. But how do you write it as a mathematical approach? I wanted you to write A is equal to 90 minus 40. And then you write it's 50 degrees. But how did you know it was 90? It's because it's right angled. Or you can just write R. Okay, so this is to show me that you understand, one, you can identify the problem, because some students may not and they just guess it. This is you're able to identify that's a right angled problem, and that's why 90 minus 40 gives me the leftover. So total is 90 minus 40 should give me 50 degrees. That's why I know A is 50. What about B? So the angle for B is this one. Now looking at your properties, what does that look like the most? Can I please have Zara in the back? It's a straight angle. Now what's the angle for a straight angle? Can I please have Zara at the front? 180 degrees, because we know it's a straight angle. So therefore B is equal to 180 degrees. That's fine, but what do you must write? I don't just want to see B equals 180. What am I missing? Straight angle. I need to see the reason. You need to justify why you know. Okay, because you'll find that some of these problems eventually you start guessing. And sometimes you guess right because it happens to be that problem. But when I draw a diagram a bit differently, you might not be able to get it right. Okay, so I need you to tell me if you can identify it. So you can see it's straight, and that's a right angle. That's why you can solve it. Let's do the next one. B. Now, for one of them, I can already solve for B very easily. Why can I solve for B very easily? Who wants to have a go with this? Fitzroy. Why is B equal to 55 degrees? What's the reason? Yes, but how did you know? By what property? Look at your 8 properties or so. Which one of those do they belong to? How did you know that this angle over here is equal to this angle over here? Well, it is acute, but that's not the reason why the opposites are equal. Why are the opposites equal, Josh? Well, that is another one too. So it's a straight line, which we can prove that later, but at the moment you can't just look at it and say it's because it's a straight line, that's why these two are equal. There's another reason. Eknor. Vertically opposite. Let's have a look at my properties again. I said that opposite angles, so this is when there's an intersection, opposite angles are the same. And that's why we know that's called vertically opposite. So if you look at this diagram, can you see there's two straight lines? 1, 2, they intersect. So that means these two opposite angles, they're opposite to one another. That's why Fitzroy knew it was equal to 55. But you see that identifying? That's what they will test. Okay, so a lot of you will be able to intuitively guess what the answer is, but that's why the reasoning matters. Because I don't know if you know it intuitively or do you know it theoretically. Okay, so here we go. Theoretically, it should be vertically opposite. That's why we know B has to be 55. Alternatively, Josh had another idea, which also works too, but you have to find out A first in order to find out B using his method. So to find A, how do you find A then? A is clearly an obtuse angle. It's bigger than 90 degrees. But what do I do here? Belinda? Oh, I see what you're doing. This is great. Can you say that slower? So you said all the angles. So this has to be A as well. You're saying if you added all the angles together, 55 plus B, which is 55 again, plus A has to equal to a full 360 degrees. Yes, that's true. Where'd you get 110 from? 55 plus 55 is 110. And you've got two of these A's. So I'll just call it double of these A's. Is equal to 360. And then you said 360 take away 110. So why did they say, or why did Belinda say 360 take away 110? It's because 110 plus what will give you 360. A quicker way to do that is do 360 minus 110. Now, if you take the total of minus 110, what's 360 minus 110? 250. So that means this answer here needs to be 250. But since you got double of them, then you half that, right? So that's intuitive. Now, there is a shorter way to do this too. So Belinda's got one technique that's correct. I'm going to call that method 1. Method 1's correct. But I want to still go back, tie it back to Josh's technique because he was correct. Let's go, Zara.
There's a line, like a straight line, 180. So then you minus 180 by 55.
Very good. So let's have a look at what Zara's saying here. So this is a shorter way than this. If this confused you, the way I laid it out, this is how you're meant to lay it out. This is algebra. But if you solve this, have a look. That's a nice straight line. So logically, in a straight line, you told me straight angle has to be 180. So that means 55 degrees is from here to here. That's 55. But then A is from here to here. If that's a straight line, it needs to add up to 180. So 55 plus A, whatever A is, needs to equal to 180 because we know that's a straight line angle. And this is where you can then do logic to it. Well, you can sit there and figure it out. Or you can do 180 take away 55, which gives you what? What's 180 take away 55? 125. And so how did you know? This is through straight angle. Now, I want to tie this back to what Josh was saying before. Can you see why when he said straight line to find B, do you realize once you know what A is, if A is 125 degrees, you can also do the same thing again. This is a straight line. This is A. So if A is 125, he was saying that straight line is now to 180. So 125 plus what? Gives you B. You could have worked out B that way as well. Okay, so there's multiple ways to do it, but you have to justify your reasoning. So to do Josh's way, you have to find A first, to then do B. If you do it my way, that was quicker to know that they're vertically opposite. Okay? All right. Let's see. Turn over the page. Turn over the page. Now, these problems look a bit more difficult, but same idea. Same idea. You need to be able to identify the problem. So here we go. Let's have a look at this one. Similar to what I just taught you just now. Can you see this is A plus another A plus another A. What kind of angle is this? Can I please have... What was that? Fitzroy? Oh, you didn't say anything? Attila? 180, because again, this is a nice straight line. The angle, if you add it all together to get that straight line, starting from here, you go here, that's acute. You go here, that's obtuse. And then you go all the way here, that is a straight line. So that means the sum of all these angles, even though I don't know what it is, I know it should be 180. Now the nice thing is, A plus A plus A, if I know it has to be 180, do you realize that's just triple of this value? So 3 times what gives you 180? Eknor. 60. A must be 60 degrees because that's the only way, or you can do 180 divided by 3 gives you 60. Please write this down. Don't just stare at your piece of paper because you might refer back to these notes later. So here you can see that dividing A by 3, 180 divided by 3, that's how you get your 60 degrees. Let's have a look at C. Now C is a bit trickier. If you focus on the lines, the ones that matter, then you can see what it is. What do we see here? Let's go with Belinda. Beautiful. Now you might not have noticed here, if I draw the lines, can you see that's one line? And I draw a second line. That's a cross. And remember, the intersection, this angle here that you have between the purple line and the yellow line must be the same as its opposite counterpart. So that means this must be 70 degrees too, because it's vertically opposite. Can you see that? So if this is 70, this must be 70 as well, because vertically opposite. So that means A plus A, these two A angles, must add up to 70. But A plus A is just double of A. You've got 2 of them. So double something gives you 70. What must A equal to then? 35. Another way to do that is you can do 70 divided by 2, half them, and you can get 35 degrees. Now the reasoning here is vertically opposite. Can you see how you're using the properties? If you can identify the properties, you can then solve. The first skill is to identify. Okay, so as you're doing fluency, you won't get to these kind of problems yet. Fluency is just to identify, then you apply to solve. Okay, so that's the first skill. Last problem for today, and then you have your session. Very similar to what we've been doing. How would you tackle this problem? Let's go with Charlotte. E, do you have a clue?
I'll start with the straight angle.
Yep.
And see that then there's like another that makes it 90 degrees.
Ooh, close, but not 90 degrees. But it's a good start. Let's go with this. So Charlotte said straight angle, which is correct. Now notice that the line that I've just colored in, that's yellow line, that's straight angle. What's the angle when it's a straight angle? 180. So that means whatever 2A is, which I don't know what it is, but I know it's acute. 2A is the result of starting from here and moving there. That's clearly an acute angle. And then from here to 3A, that's an obtuse angle, right? So this is acute. This is obtuse. But together, acute and obtuse will make this nice straight line, which is 180. So what that tells me is the acute is 2A, plus the obtuse, which is 3A, it should equal to 180 degrees. But what you realize is when you say 2 double of A and then triple of A, that's the same thing as saying 5 times A, because you got 5 of them. So 5 times something has to equal to 180, and again, you can sit there and guess it, or you can do 180 divided by 5. Now, what's 180 divided by 5? That's easier. That is 36. So A must be 36 degrees, and this is one of the harder problems. So this is problem solving, but it starts off, can you see I'm using a lot of the straight line angles. For all of the 6 problems we just did, I'm relying back on the straight angle. Yeah, so straight angle, vertically opposite are very key. That's a hint for you as you're doing exercise 2A. All right, the time is 2:31, so you have more than 40 minutes to start on exercise 2A and pretty much finish 2A because That's all asking for homework by the end of this week. Okay, next lesson is 2B. I still follow the planner. We're still doing 2C. Yeah. I don't have you Tuesday, by the way. I don't have you on Tuesday.